Hello students, welcome to the video lectures of speech and natural language processing. So today we are going to discuss about diphone waveform synthesis concept. So we are in our fifth unit. So now the concept is about diphone waveform synthesis. So what is diphone waveform synthesis? So basically the diphone waveform synthesis is a speech synthesis technique. Okay, it tries to combine the pairs of adjacent speech sounds. So adjacent speech sounds are nothing but the diphones, which we have discussed in our previous unit as well, and also in our previous video lecture. So where a diphone is defined to be the segment of speech that covers two adjacent phonemes. So again, what is a phoneme? So we have seen the difference of pat and bat in our previous video lecture, where a phoneme is the smallest unit of sound in a language that can differentiate meaning. Okay. So the diphone waveform synthesis is a speech synthesis technique where the basic building blocks of speech known as diphones are used to generate synthetic speech. A diphone represents the transition between two adjacent phonemes, capturing the acoustic properties at the boundaries between these sounds. Okay. So basically, the primary advantage that exists with our diphone waveform synthesis is that it produces more natural sound. Okay, when compared to the earlier methods or traditional methods, this will try to produce more natural sound. And the key concepts that exist in our diphone waveform synthesis. Let us see them. So first is diphone, where a segment of speech that starts in the middle of one phoneme and ends in the middle of the next phoneme. Okay, so for the word cat, you can see the diphones which are mentioned here, where the segment of the speech that starts in the middle of one phoneme and ends in the middle of the next phoneme. So cat, C-A-T, cat. Now you see K and this phonetic transcription, okay, of starting with the K, getting into the middle and moving forward to the T. Second is corpus. A pre-recorded database of diphones is collected from a speaker. Again, what is a diphone? What is a diphone? A diphone is a unit of speech sound. Okay. So, which already I told you, which consists of the two adjacent phonemes. Again, what is a phoneme? Phoneme is the smallest unit of sound in a language that can differentiate the meaning. So now a pre-recorded database of diphones is collected from a speaker, and typically around 1500 diphones are sufficient for most languages. Next is concatenation is the another key concept in diphone waveform synthesis. Concatenation is diphones from the corpus are concatenated to generate continuous speech. Smooth transitions between diphones are ensured to maintain naturalness. Synthesis process. Select diphones corresponding to the desired text. Apply signal processing techniques for prosody adjustment. Examples are pitch and duration. So concatenate the diphones into a waveform. So next, steps in diphone waveform synthesis. First, database preparation. Record a human speaker reading a specially designed script to cover all diphone combinations in the target language. Example, English requires approximately 1500 diphones. So basically we need a database, right? So that is what is the first step in any diphone waveform synthesis, where we have to collect a database. So record a human speaker reading a specially designed script to cover all diphone combinations in the target language. So here we are making a database which is efficient of covering the entire linguistics or entire your particular diphone combinations. Second is diphone extraction. So segment the recorded audio to extract individual diphones. Store them as digital waveforms. That is diphone extraction. Next is text to phoneme conversion. So convert input text into a sequence of phonemes using linguistic rules or models. Example is cat. Diphone selection. Retrieve diphones corresponding to the phoneme sequence from the database. Okay. Again, phoneme is the smallest unit of sound in a language that can differentiate the meaning, which is also described with a best example of alphabets B and P, that is bat and pat. Okay. Next, Concatenation and smoothing. Concatenate selected diphones, use signal processing to smooth transitions and ensure natural prosody. Example, overlap add techniques reduce abrupt changes at boundaries. Next is output speech signal. So it generates the final waveform for playback. Next, we talk about the applications. First application is text to speech application. That is text to speech systems, TTS we say, which is used in virtual assistants, accessibility tools, and automated announcements. Second one is language learning tools, which helps non-native speakers practice pronunciation with accurate sound transitions. Then is research in phonetics and linguistics is the third application, which is used to study phoneme transitions and prosody. Again, prosody is what? Prosody is the speech, the pitch, intonation, stress, and all those things, right? So we have seen in our previous topic, which was prosodic analysis, right? So where the prosodic analysis will examine the rhythm, intonation, stress, and pitch of the speech. Next, assistive devices, which enables communication for individuals with speech impairments. And let us see the advantages. First one is natural sounding speech, so which captures transitions between phonemes, leading to more natural speech synthesis than earlier format synthesis methods. That is the first advantage. Next, compact database requires fewer units compared to full word or phrase storage systems. Okay. Next is high control. So allows precise manipulation of pitch, duration, and stress. Okay. So these are all the advantages. So that is natural sounding speech. So which helps in producing the natural sound that captures transition between phonemes, leading to more natural speech synthesis. Okay. Next, challenges. Challenges are, first one is boundary artifacts. So boundary artifacts is discontinuities may arise at diphone boundaries, requiring smooth techniques. Second is limited expressiveness. That is, prosodic variation is constrained by the original recordings. Okay. And next is a language specific database. Each language requires a separate diphone database, increasing resource requirements. So next is recording quality. So high quality recordings are essential to ensure intelligibility and naturalness. Okay. Then example workflow. Suppose if the given input text is, I am learning speech synthesis. The steps involved are where first it converts text to phoneme sequence. So now this is I, this is am, this is learn, this is speech, this is synthesis. So each one is the phonetic representation of the given input text. I am learning speech synthesis. So you can see here, I am learning speech synthesis have been converted to phoneme sequence. This is I, this is am, this is learning, this is speech, this is synthesis. Second, extract diphones from the database. So wherever you have diphones, those are extracted. So from I, this A, from I, this is the diphone extracted. Next, from each and every word that is given as an input, the diphones are extracted in the following manner. Next, third step, concatenating diphones. That is, concatenate the diphones. So smoothly join diphones to form the full utterance. Next step is to apply the prosody. Prosody is again examining the stress, pitch, intonation of the speech. So adjust pitch and duration for natural intonation. So last is output synthesized speech. So thank you, students.